Hi, so I just want to tell you guys quickly that the clip you're going to see in this video was filmed back when I was in UK in November 2019. So that's way before all the COVID-19 and the lockdown. Think of this as a kind of virtual museum tour before you can go back to do the actual museum tour. Enjoy! Hi guys, so I'm at the History of Science Museum in Oxford right now. So I've looked this place up online before I come in because I'm interested in the history of science in general, and I really have no idea what to expect when I come here. But right now, the only thing I have to say is, oh my god, have a look at this. Like wow, just wow. And this is only the first room. Guys, look. This is a 6 prism spectroscope. So according to the card here, it says it's for dispersing the light from the sun. I don't know why you need 6 of them exactly to do this. Because you know, if you direct a small enough beam from the sun, you should be able to kind of get a good, you know, diffraction out of the beam using 1 or 2 prism already. Like what kind of spread would you get from a 6 prism, and how would that help you measure, like what are you measuring from this thing? Like I'm really curious about this. Okay guys, make a guess what that is. Those are the microscopes. Yeah, it looks very chunky, isn't it? That's probably because the lens are really big inside. That's why it has to, you know, be huge to accommodate the lens. So we have, you know, we have better optics and better technology to make that much smaller nowadays. But back in the day, that's the limitation. That's how they could do it. Yeah, but even though that's chunky, I would like to draw your attention to all the decorative details that they have up there. Like, old scientific instruments are not just instruments, like they are pieces of arts. Like, just look at how shiny and, you know, well made and just beautiful these things are. Like, and they are expensive, like, not to, you know, like, these are in, you know, many ways as much working equipment as, like, plaything for the riches. That's why they look this good. So these are the leaner and meaner version of the microscope. So if you look at it, the constructions are entirely different, isn't it? There's a lot more downstairs, and a lot more upstairs. This is basically the basis of what we have for the modern microscope now. And these are more of working equipment now, so they're not as pretty. But, you know, these are, technological wise, these are, you know, still a thing of beauty. So, you know, I would still put these things on mantle just to look at them and cherish all the knowledge and craftsmanship and everything that, you know, the engineers and the worksmen put into, you know, crafting these things. Like, optics are not easy, people, so are engineering. What? Just look at these things of beauty. Ooh.
So these are little tiny sundials that you keep in their pockets. Well, they used to be the way people would tell the time.
These basically are your ancient pocket watches. So they're sundials and, you know, with compasses, so that you can tell time that way. Aren't they amazing? So apparently one of these three gentlemen is Tycho Brahe. I would make a wild guess that he's the one over there with the ruffle. I'm not entirely sure. But he looks like the oldest among the three, and the card said the other two, Flimstead and I am so sorry, I cannot pronounce the other gentleman's last name, are a great admirer of Brahe. So my guess would be that that's the one. Hi Tycho. So, you know, if you think a telescope can only be brass and boring, may I introduce you to the Ford telescope and the dog and dash and kind of this ivory and the leather and this kind of marble-esque telescope. So this is actually the camera up here. So that is the opening where the light comes in, and this is where the image is going to be projected at the end. And as this picture shows, this diagram here, you normally have something to capture the picture, namely a paper and a person and something to draw that image on. So that's normally not a very sophisticated way of doing it, but there are a lot of pictures. I don't remember back when, but on this card here it says this picture is from the early 18th century, but I think it might be even before that, that actually artists and painters have used this technique to actually imbued realism into their painting, and use this technique to kind of capture actually real images, and then, you know, essentially like tracing the real image and then paint over them, which by the way is a totally legit way of kind of, you know, studying and making images. But you know, if you do that by tracing another person's work, then, you know, that's copyright infringement. That's a different thing. But of course, if you change the way of capturing the image from a person tracing the image onto a paper to a film with a chemical that is sensitive to light, then what you have is a camera. And this one in particular was at one time owned by Lawrence of Arabia.
Yeah, like I don't think I like seeing it, but I don't.
Just, you know, let's just stand here and just bask in that knowledge for 3 seconds. By the way, this is also a camera, but the size of this thing and the size of this film make that camera look absolutely portable. And I think this is supposed to be portable too, because it's called a collapsible Let me look at it again. It's a collapsible web plate camera. So in some way it's marketed to be portable. But as you look at the size of it, how on earth is this thing portable? Like, wow, just look at the lens. Like, just have a look at the lens. Like, I can probably fit my camera into that lens if I really try to. Like, not through it, but just like fit it into that brass thing. Like, what? Oh. Technology and progress. I love you. This is a book by Tycho Brahe. Okay, let's just stand here and bask in the aura of Tycho Brahe for a second, and acknowledge the fact that I don't understand a word because they're all in Latin. Like I can see the word parte, acque. Yeah, I can recognize the Latin, but that's about it. You know, it's a time where, you know, basically all scholarly work are written in Latin, and the people back then think that, you know, the night sky is basically painted up there by God, so nothing's supposed to change. But, you know, our dear boy Tycho basically measure all the stars in such accurate details that he can show that they do change. So this is groundbreaking stuff right here. And as you can see, we physicists have been doing diagram since basically the start of physics. So, you know, if you're going into physics, make sure you know how to do this shit as fast as possible, okay? Now this is another book, but this one is in English, and it's also written by a woman, Miss Caroline Herschel. It's a catalog of stars, and this is her explanatory remarks. I hope you can kind of read this. Yeah. And I'm not basking because you can read her words, and women words should be read, okay? So read that. And I love just how big this is, and I think it should be big because this is basically a collection of data. So that, at least that's what I understand, because I can't actually touch the book. So that's why it has to be huge. Back in those days, you know, you don't have simulations, you don't have database online that you can access. So this is how you access the data. You print them. This is also kind of how people like Copernicus were able to test his model. Like he has these kind of catalogs to be able to look into and test out whether like his model fits with the measurement data that comes out of, you know, all the observatories like in the Middle East, in Baghdad and places like that, where the measurement technologies are at the most precise at the time. And yes, the Middle East were basically at the cutting edge of astronomy back in the day, before the Renaissance comes in, basically. So that they were the one producing the data that Copernicus uses for, you know, his heliocentric model. And apparently, according to this card right here, this is the data set that Caroline Herschel uses to discover 8 different comets. So that's pretty awesome because, you know, back in those days, people don't know what comets are. This is really cool. So this is a really cool activity here too. So they have a setup here that allows basically people who are curious about how the eye works in general, just to come in and perform experiments and dissections and things like that to study sights and optics and eyes. So the closest table over here, they're doing a dissection of pig's eyes. And there was just like these bunch of college students just comes in and starting dissecting a new I'm supposing a new set of pig's eyes, but there were just a bunch of like primary school kids were just here doing the same thing just moments before. Over there on the far table over there, they were testing out how basically optics of the eyes work. So that was pretty cool. That looks pretty fun. And I actually am really glad that there are like this kind of like personal interactions between like demonstrators and like kids who are coming in to learn these things. Just because, you know, that's when the learning happens the most. Because like in my like personal experience teaching science, like when learning happens in its most efficient form is when there's like personal interactions between the teacher and the students, and there is like discussion and curiosity of the student is pursued. And you know, if there is no answer, then you say, I don't know, and let's investigate, and things like that. And that is not satisfied when you're just, you know, walking through a museum and reading things and looking at videos, or just, you know, play with toys and exhibits. You do that by talking to people and people with knowledge. And so this is the setting where scientific knowledge and thinking is transferred. This is how it should be done, people. So, 3 guesses what that is. It's actually a sundial. Yes, it's a hexagon of a sundial, but it's supposedly every surface there, when used correctly, can tell you time according to the direction of the sun. Like whoever designed that thing is a genius. That is a thing of beauty. Just look at the detail. Just look at the detail of this thing. This is so pretty. And it can tell you the month. Or are you supposed to adjust it to the month? I'm not entirely sure. In any case, this is beautiful. Oh my god. Oh my god. Why don't we make this kind of thing anymore? So this is the instrument made by the East Indian Company, which is the name that anyone who actually comes from the East, when we heard it, would shiver, because we know what happens when they come around. That being said, this looks like fun, to be honest. Like, I would want to learn how to use these things. Okay, one thing I really like about this museum is the audio guide system, because as you can see here, there's no number at all, unlike most of the museum that you're gonna find. But really, all you need to do is, as you can see here, so this is the audio guide, so there is no like number selection either. You just go. I hope you can hear that, at least. Otherwise, it's just going to be a blurred picture of this going around. But that's how you start the audio track for this particular display. And that's about it. That's really simple. Just look at this astrolabes. these beautiful, beautiful astrolabes. These are Turkish, like Ottoman Turkey, and they are all designed for different things. Those up there are Persian. That's why all the designs are different. Like, I know a lot of Iranian people back in Canada, and you guys, shout out to you guys know how to do art. Like, those are gorgeous. This one is from Lahore, also beautiful. Why must the Spanish one be so spiky? And this is the greatest one of them all. This is the Eastern Islamic spherical astrolabe, the only surviving one. So, you know, astrolabes are supposed to be used to calculate things in the sky, basically. So those are spherical planes. But as you can see, most astrolabes are flat. So that is actually a projection of basically a spherical surface onto a flat plate. So the same way you would project the surface of the Earth onto a map. This is, however, how it's supposed to be. But I don't know how you would use it. Like, not that I know how you would use that, but I'm even more confused with this thing. It's very pretty though. It's even more pretty this way. I want one of them now. How do I make one of these? Okay guys, do you know what this is? This is actually a pocket watch for seafarers. So it's not actually for keeping time in the sea. Well, technically it is for keeping time in the sea, but it's actually for calculating your position in the sea. Watch is kind of suspended inside that box with all that brass protection that you see. So all that is so that the movement of the ship is not affecting the precision of the mechanics inside. In that way, you don't have, you know, weird lag or, you know, what do you call it, when the time go faster than you want it to be, or what it's supposed to be. Yeah. So basically, you want to keep the timekeeping as precise as possible, so that you can keep track of where you are on the surface of the Earth. And that's the principle of that. By the way, this is the reason the British were able to conquer the world through, you know, conquering the Navy. So if anybody has a bone to pick in the future and you have a time machine, you go back and sabotage this, okay? And that's all you need to do. Oh my god, people. This display case is just basically all the calculators we have invented throughout history. Like, I don't even know what this thing is. Like, I have no idea how this thing works. Like, I can kind of figure out what this is. I've kind of seen a similar one works before. I have no idea what that is. This is, you know, the good old calculator that we always used. That's the abacus. I kind of know how to use, but I've never seen one that small before. And please do not tell me that is an abacus for a Roman numerals. Like, really? Really? Like, Roman numerals should be cancelled a long time ago. Also, early adding machines, which is actually not an adding machine according to the card. It's just like you keeping tracks of what you're adding. That's all. But this is the gem. This is Babbage, difference engine. So these are assembled from what is left from Babbage's project. So, which probably means there are more than this. That would be my guess. But this is all they have left. because of course that project never really result in an actual difference machine. They closed it down after 20 years, and Babbage basically take up too much money for it to be a viable project for the government to support. Which I can understand the government, like why would you want to have a different engine that costs you basically an equivalent of like millions of pounds in today's money, when you can have a person do it for you, right? But then who would have thought that 100 years later this thing would lead to them having the Colossus in the war? Who would have known? Okay, I have to admit now that I feel very cheated, because this is Napier's rod, and what they do essentially is they allowed you to multiply and divide without actually having to multiply and divide. I feel like I've been cheating out of the hours I spent memorizing the multiplication tables when I can be using this thing. Why? So finally I'm done basically gushing over every display cabinet ever inside the History of Science Museum. So basically it's the building over at the back there, but that's not the entrance, by the way. The entrance is right over through that door over there out in the street. It's just over here is a little quieter. I would say it's a small museum. Like in total it's just like 3-story. Like the building is not really big at all, if you can see from here. Like that's essentially just how big it is, just how wide the building is, and it's not very long in that direction. But the collection is actually pretty good. It's mostly astrolabes and sundials and globes, but there are a lot of varieties, and there are also other smaller pieces that you can have a look. If you're interested in the history of science, and if you're like scientific instruments, and especially if you're a lover of intricately made astrolabes in particular, I highly recommend that you check this place out. It's basically in between Exeter College and the Bodleian Library, so right at the heart of Oxford Zoo. You can't really miss it. And since it's getting dark and it's getting cold, I'm gonna see myself to a pub now. See ya.